Welcome back to Tech Daily. I'm Oliver, and joining me as always is Jane. Today's June 12th stories paint a fascinating picture of how fundamentally AI is reshaping business and software development. We're looking at companies like Gamma hitting $2.10 billion valuations, with just 50 employees, zero marketing spend, and pure word-of-mouth growth. But that's just the beginning of what we're seeing.
Absolutely, Oliver. And what's striking is this isn't just about scaling up existing models anymore. We're witnessing this major transition from AI as a tool that responds to prompts to AI as autonomous employees that can execute entire workflows independently. The stories today show this shift happening across everything from GitHub's new agent capabilities to how developers are completely rethinking their workflows.
That's the key insight. We're seeing a paradigm shift from application-first computing, where humans route between different apps, to agent-first computing, where you delegate complete jobs to AI systems. And the data is remarkable. Some users are burning through 500 million tokens daily, not because they're chatting more, but because they're handing over entire multi-step processes.
Exactly. So today we'll dive deep into Grant Lee's playbook for building Gamma, explore what this agentic AI shift really means for competitive advantage, look at which AI tools actually deliver on their promises versus just good marketing, and examine how GitHub is positioning itself as the AI development platform. Plus, we'll break down this concept of spec-driven development and why understanding AI's capability progression matters for business planning. Let's dive into this Gamma story because it really challenges conventional startup wisdom. Grant Lee and his team built an AI presentation tool that hit 100 million users and a $2.10 billion valuation with just 50 employees. But here's the kicker. Zero paid marketing. Absolutely zero. This was pure word-of-mouth growth.
That's remarkable scale efficiency. But what I find fascinating is how they chose what to build in the first place. Most entrepreneurs get stuck on market sizing and competitive analysis. What was Grant's approach?
This is where it gets interesting. Grant talks about the energy test. They actually had two parallel ideas running for 6 months, but they chose presentations because, in his words, the team couldn't stop thinking about it. He emphasizes that energy and imagination depth matter more than market size. It's about which problem space pulls at you intellectually.
That's a very different filter than what most VCs would recommend. But speaking of VCs, his fundraising approach was equally unconventional. Can you walk through that sprint strategy?
Oh, this is wild. Grant ran over 100 investor pitches in just 2 weeks, but here's the catch. He did them all from 8 p.m. to 2 a.m. after putting his kids to bed. Initially had less than a 50% success rate, but it snowballed through warm introductions. The key insight is he treated it like a true sprint, 2 to 3 weeks max, with one founder running point, not this months-long drag that kills momentum.
The time constraint actually seems like it would improve the process. You're forced to adapt quickly based on feedback. But let's talk about product market fit. How did they know they had it without traditional metrics?
Grant has this elegant 2-part test for product market fit. First, organic growth. People tell their friends without any prompting from you. Second, willingness to pay. Credit cards come out if the value is really there. No complex analytics needed. If you have both happening naturally, you've got something.
That's beautifully simple. But achieving that organic virality isn't accidental. What did they do differently in terms of team composition and product development?
This is crucial. They over-indexed on product designers early. 1/3 of their entire company was designers because design quality drives virality. People share things that look and feel exceptional. But they also hired painfully slow, looking for generalists who spike in one area but can cross domains, like designers who can also code and ship features end to end.
That hiring philosophy makes sense when you're staying lean. but I'm curious about the early customer development. How did they validate the concept before building?
Grant's rule is brutal in its simplicity. Spend all of the first 30 days talking to customers, not building in isolation. Don't disappear into a code cave or design studio. The early conversations shape everything about how you build and position the product. It's customer development as product development.
And this approach, team before, idea, energy test for validation, sprint-based fundraising. What does this mean for solo entrepreneurs who don't have co-founders to start with?
That's the interesting tension. Grant emphasizes assembling complementary co-founders first, then exploring the problem space together. But the principles still apply to solo builders. The energy test for idea selection, the customer-obsessed first 30 days, building organic virality into the product from day one. The difference is you might need to be more deliberate about finding those complementary skills, whether through hiring, partnerships, or just acknowledging where you'll need help.
What strikes me is how this validates the AI-assisted approach to building businesses. Gamma achieved $100 million ARR with 50 people, partly because AI tools let small teams punch above their weight. The timing seems perfect for solo builders who can leverage AI to fill capability gaps.
Exactly, and Grant's emphasis on constant pricing experimentation rather than set and forget models shows how these lean AI-assisted teams can iterate faster on business fundamentals. They're not selling dollars at a discount because they can adjust unit economics in real time. It's a completely different operational model than traditional software companies.
Now, this Gamma story actually illustrates a much broader shift that's happening right now. We're seeing AI cross a fundamental threshold, from being passive tools that respond to prompts to becoming autonomous employees that can execute entire workflows without continuous human oversight.
That's a crucial distinction, Oliver. When you say autonomous employees versus tools, what does that look like in practice? Because I think a lot of businesses are still thinking about AI as glorified chatbots.
Exactly right. The old model was prompt-based. You ask ChatGPT a question, it gives you an answer. Conversation over. But agentic AI can take on complete workflows. Instead of asking, write me a marketing email, you can delegate, manage our email marketing campaign, and the AI handles research, segmentation, writing, scheduling, A/B testing, and performance analysis independently.
So we're moving from augmentation to delegation. That's a massive operational shift, and I think this is where competitive advantage starts to compound, right? Because if your competitor is still using AI to assist their human workforce, but you're using AI to replace entire workflow segments, you're operating at fundamentally different cost structures and speeds.
That's the key insight. This isn't just about productivity enhancement anymore. Organizations deploying autonomous agents are building structural advantages. They can iterate faster, operate leaner, and scale without proportional headcount increases. We're seeing early adopters pull ahead rapidly.
And this is why waiting poses such a competitive risk. It's not like waiting for the next iPhone where you miss some features. If your industry starts deploying agentic workflows and you're still treating AI as a fancy search engine, you could find yourself permanently disadvantaged. The gap compounds quickly.
Right, because implementation requires completely rethinking business processes. You can't just drop autonomous agents into existing workflows designed for human handoffs. Companies need to restructure around delegation rather than augmentation. And that takes time to get right.
Which brings us back to companies like Gamma minus 50, people doing the work that traditionally required hundreds, not because they're working harder, but because they've redesigned their operations around AI as workforce rather than AI as assistant. That's the paradigm shift we're really talking about here. Now, while we're talking about this agentic shift, Let's get real about what AI tools actually deliver versus what they promise. XDA developers just published a fascinating comparison that really cuts through the marketing noise. They tested 3 major AI presentation tools: Claude Design, Microsoft Copilot in PowerPoint, and Google Gemini in Slides, on the same complex presentation task.
And I'm guessing the results weren't as uniform as the marketing materials would suggest. These companies all claim similar capabilities in their demos.
Exactly the problem. Despite comparable feature sets and marketing claims, only one tool actually delivered professional quality results. The others produced what you'd generously call demo quality output. This is crucial for anyone building businesses where presentation quality matters. You can't just assume all AI design tools are interchangeable.
That's a perfect example of why testing methodology matters so much. Simple demos hide these quality differences. But I want to contrast this with a more successful AI implementation I came across, someone using Claude Code for Docker infrastructure cleanup. What's interesting is how they approach the autonomy question.
Tell me about that approach, because I think this gets to the heart of when AI tools actually work versus when they fall short.
This developer had years of accumulated Docker Compose chaos in their home lab, dozens of containers, inconsistent formatting, poor documentation. Instead of letting Claude autonomously manage their infrastructure, they used it as a refactoring assistant. Claude handled the tedious work, standardizing YAML formatting, adding comments, documenting environment variables, but the human reviewed every single change.
So they treated it as a cleanup assistant, not an infrastructure autopilot. That's actually a much more reliable pattern than full delegation. The result was better documentation and consistency without the risk of autonomous systems making critical infrastructure decisions they couldn't understand or trust.
Exactly. And this highlights the gap between the agentic future we discussed and current AI reliability. Marketing promises autonomous employees, but practitioners who succeed are still maintaining tight control loops, especially for mission-critical workflows. The tools excel at tedious, well-defined tasks, but struggle with judgment calls.
Which brings us back to tool selection strategy. Rather than choosing based on feature lists or marketing claims, you need to test on your actual use cases. The presentation tool comparison shows that capability gaps are real and significant. What works for a demo might fail for production work. The Docker cleanup example shows that constrained, human-supervised AI often outperforms promised autonomy.
Speaking of infrastructure for AI workflows, GitHub is making some really aggressive moves to position itself as the platform for agentic development. They just released an agent device CLI tool specifically designed for AI agents to programmatically control iOS and Android devices. This isn't just another developer tool, this is GitHub saying AI agents should be first-class citizens in the development ecosystem.
That's fascinating, but what really caught my attention is what this reveals about GitHub's broader infrastructure. When you look at the repository page, you can see feature flags for extensive Copilot integrations, coding agents, mission control, task automation, even token-based billing, and custom copilots. They're building a comprehensive AI development platform, not just adding AI features to existing tools.
Exactly. And they just eliminated a major friction point for adoption. GitHub Agentic workflows now support GitHub token authentication instead of requiring personal access tokens. That might sound technical, but it's huge for practical deployment. No more creating, storing, and managing long-lived credentials just to run AI workflows.
That credential management overhead was a real barrier, especially for teams trying to scale AI workflows quickly. But what does this tell us about GitHub's strategy? They're not just facilitating AI development, they're architecting the entire environment where AI agents operate. Multi-agent capabilities, session management, task sharing, environment controls. This is platform thinking.
And the integration points are telling too. They're supporting external tools via Model Context Protocol Registry, which means they're positioning GitHub as the orchestration layer for AI development, not trying to own every piece of the stack. The agent device CLI particularly intrigues me because it suggests AI agents controlling mobile devices for testing, automation, even integration with IoT systems.
This is classic platform strategy. Make it easier to build on GitHub than anywhere else, then capture value through the ecosystem. By eliminating authentication friction and providing native agent capabilities, they're reducing the switching costs for AI development workflows. Once your agents are running on GitHub Actions with GitHub Token, why would you move them elsewhere?
It also reinforces that shift we talked about from application first to agent first computing. GitHub isn't just adding AI features to their existing platform, they're redesigning the platform around the assumption that AI agents will be primary users, not just assistants to human developers. That's a fundamental architectural bet on where software development is heading.
Now, while GitHub is building the infrastructure for AI agents, we're also seeing the creation tools get much more accessible. Noose Research just released something called the Hermes Agent Profile Builder, and it's a perfect example of how agent creation is being democratized. Instead of manually editing configuration files and wrestling with command line setups, you now get a unified dashboard where you can configure everything: agent identity, model selection, skills, and MCP server connections, all in one place.
That sounds like a significant reduction in technical barriers. But I'm curious about the scope here. When you say agent identity, what level of customization are we talking about? And how does this compare to the fragmented workflow developers had to deal with before?
It's quite comprehensive. You can define the agent's name, persona, system prompts, basically its entire personality and behavioral framework. Previously, you'd have to edit multiple configuration files, set up command line environments, manually connect different services. Now it's visual and consolidated. Plus, you can create multiple agent profiles and switch between them, so you might have one specialized for code analysis, another for content generation, another for data processing.
The multiple profiles aspect is intriguing because it suggests we're moving towards specialized AI workforces rather than general-purpose assistants. But what really interests me is how this fits with the broader no-code, low-code movement. Are we looking at a future where non-technical business users can spin up their own AI agents for specific workflows?
That's exactly the trajectory we're on. The MCP server integration is particularly powerful here because it brings tool calling capabilities, FISA-SMELT access, web search, API connections, directly into the Visual Builder interface. So a marketing manager could theoretically create an agent that monitors social media mentions, pulls data from their CRM, and generates response strategies, all without writing a single line of code.
That's a fascinating democratization of what used to be highly technical capabilities. But I wonder about the quality and reliability trade-offs. When you lower the barriers to entry this dramatically, do you risk creating a lot of poorly designed agents that don't actually solve business problems effectively?
That's a valid concern, and I think it's why the open source approach matters here. Hermes Agent is positioning itself as a self-hostable alternative to commercial platforms, which means organizations maintain control over their agent infrastructure and can establish their own quality standards. But you're right that easier creation tools could lead to a lot of experimental agents that never deliver real value. The key is probably in the iteration cycle. These visual builders need to make it as easy to refine and improve agents as it is to create them initially.
And this connects back to our earlier discussion about the shift from tools to autonomous employees. If business users can create specialized agents through visual interfaces, we're potentially looking at a much faster adoption curve for agentic workflows. The bottleneck shifts from technical implementation to business process design and change management.
Exactly. The Hermes Profile Builder represents this broader trend where the limiting factor isn't technical capability anymore, it's organizational readiness to delegate workflows to AI agents, and the creativity to identify which processes benefit from automation. When agent creation becomes as simple as setting up a Slack workflow, the real challenge becomes knowing what to automate and how to measure success.
Now, while we're seeing all these advances in AI tooling and agent creation, there's an important framework that I think helps make sense of where we are and where we're heading. Carlos Perez has this concept called the LLM capability ladder that argues AI advancement isn't actually chaotic or unpredictable. It follows a very structured progression.
That's interesting because the common narrative is that AI capabilities emerge suddenly and unpredictably. These emergent behaviors that nobody saw coming. What does Perez mean by a predictable ladder structure?
Exactly. That's the misconception he's challenging. His argument is that each capability tier builds on previous foundations. So an AI system can't suddenly develop advanced reasoning without first mastering basic language understanding, pattern recognition, and logical inference. It's like climbing a ladder. You can't skip rungs. Each new capability requires mastery of the prerequisites below it.
Yeah, so if that's true, this has huge implications for business planning and automation strategy. Instead of waiting for miraculous breakthroughs, you could actually predict what capabilities are coming next based on what's already been achieved. But how do you know where your particular use case sits on this ladder?
That's the strategic insight. Understanding the ladder structure helps you predict which tasks can be reliably automated now versus which require waiting for next-tier models. For example, if your workflow requires multi-step reasoning plus real-time adaptation plus creative problem-solving, you're probably betting on capabilities that are several rungs up from where we are today.
Right, and that changes how you think about building AI-assisted businesses. Instead of hoping for breakthrough capabilities to solve your hardest problems, you design around the current rung of the ladder and plan upgrade paths as new capabilities become reliable. But what about the limits? Perez mentions that ladders eventually reach a plateau. How do you know when you're approaching architectural constraints?
This is where it gets really interesting for strategic planning. Perez argues that the end of the ladder isn't just current technical barriers, it represents fundamental limits determined by the underlying architecture. So transformer-based models might have a different capability ceiling than whatever comes next. The key insight is that not all architectural approaches will reach the same height.
So, for businesses, this means you need to understand not just what's possible today, but what's likely to remain impossible with current architectures versus what might unlock with future approaches. That's actually a more nuanced planning framework than just assuming exponential improvement forever. You can bet confidently on near-term rungs while being more cautious about capabilities that might require architectural breakthroughs. Now, while we're talking about AI capability progression, there's a really significant development that's transforming how knowledge workers can actually trust and use AI-generated content. NotebookLM's May 2026 update introduces something that fundamentally changes the trust equation: citation transparency. Instead of getting AI-generated insights with no way to verify where they came from, you now get inline citations and source attribution for everything the AI produces.
That addresses one of the core barriers to AI adoption in professional settings, doesn't it? I mean, you can't use AI-generated analysis in a business context if you can't trace back to the original sources. But how granular is this attribution? Are we talking about document-level citations or something more precise?
It's quite sophisticated. The system maintains connections between specific insights and their original context, so you can verify individual claims against source material. But what's really interesting is how this integrates with broader productivity workflows. There's this emerging stack that people are using: Obsidian for structured note-taking with bidirectional linking, Notion for project management and collaboration, and Raindrop for content curation and bookmark management.
So, NotebookLM sits at the synthesis layer of this stack. Help me understand the information flow here. How does content move from capture through to actionable output?
Exactly right. The workflow becomes capture with Raindrop, where you're collecting and curating sources, organize with Obsidian using that Zettelkasten-style linking methodology, synthesize with NotebookLM, where AI processes your research and generates insights with full attribution, and then execute with Notion for project management and team collaboration. Each tool handles what it does best, but they work in concert.
That's a much more sophisticated approach than trying to do everything in one platform. But I'm curious about the trust implications you mentioned. How does verifiable AI output change the way professionals can actually use these tools in high-stakes environments?
This is huge for knowledge work where accountability matters. Before this update, you might get brilliant AI-generated insights, but you couldn't stake your professional reputation on them because you couldn't verify the reasoning or check the sources. Now you can use AI to help synthesize complex research, generate strategic recommendations, even draft reports, but every claim is traceable back to your source material.
So we're moving from AI as creative assistant to AI as research partner. But this raises interesting questions about the skill sets knowledge workers need to develop. If AI can handle synthesis and generate insights from your collected materials, what becomes the uniquely human contribution?
That's the evolution we're seeing. The human value shifts to curation. What sources do you choose to include? What questions do you ask the AI to explore? How do you interpret and contextualize the synthesized insights for your specific situation? And critically, knowing when to trust the AI output versus when to dig deeper into the source material yourself.
It reminds me of that capability ladder concept we discussed. The AI has clearly mastered information processing and synthesis, but the strategic thinking, contextual judgment, and domain expertise still require human intelligence. The citation transparency essentially lets you audit the AI's reasoning process.
Exactly, and this connects back to our earlier discussion about tools versus autonomous employees. In knowledge work, we're seeing AI become more autonomous in processing and synthesizing information, but it's still operating under human direction and oversight. The citation feature makes that oversight much more effective because you can actually verify the AI's work rather than just hoping it got things right.
What strikes me is how this productivity stack approach mirrors the tech stack consolidation trend we're seeing in other areas. Instead of one monolithic solution trying to do everything poorly, you're getting specialized tools that excel at specific functions but integrate seamlessly. And for knowledge workers, this could dramatically compress the time from research to insight to action.
That compression is key, especially in fast-moving industries where the ability to quickly synthesize information and generate actionable intelligence becomes a competitive advantage. But it also requires knowledge workers to become much more intentional about their information architecture, how they capture, organize, and connect ideas. The AI amplifies whatever system you bring to it.
Which brings us back to that theme of humans evolving from doing the work to orchestrating AI that does the work. In knowledge work, success increasingly depends on how well you can design information workflows that leverage AI capabilities while maintaining the verification and judgment layers that ensure quality output. It's workflow design as core competency. Now, here's a statistic that really puts this entire AI transformation in perspective. Only 1 in 1,600 people are actually using Codex, but those who do are burning through 500 million tokens daily. And here's the crucial point. That massive token consumption isn't because they're having longer conversations with AI. It's because they're delegating entire workflows to agents that execute multi-step processes across their entire computer environment.
That's a fascinating usage pattern, Oliver. So we're talking about a fundamental shift in how people interact with computers, moving from this application-first model where humans route between different apps to agent-first computing where you delegate complete jobs. Can you give me a concrete example of what that 500 million token usage actually looks like in practice?
Absolutely. Instead of manually switching between applications, say opening Slack, checking email, updating a spreadsheet, then writing a report, users are creating what they call Chief of Staff threads. These are persistent AI threads that know your goals, understand your file structures, and maintain context about your standards and processes. You might tell it, prepare the quarterly review, and it handles research, data compilation, document creation, and stakeholder communication autonomously.
That chief of staff concept is brilliant because it mirrors how executives actually work with human assistants. But I'm curious about the reliability factor here. When you're delegating entire workflows rather than individual tasks, how do users maintain control without micromanaging every step? That seems like a major trust leap.
This is where the approach gets sophisticated. Successful users aren't just giving vague instructions, they're defining clear objectives with specific completion criteria. It's the difference between saying, help me with marketing, versus create a customer acquisition dashboard that pulls data from Slack, email, and our CRM, updates daily, and highlights leads requiring immediate follow-up. The AI executes the job, but within well-defined parameters.
So it's goal-oriented delegation rather than open-ended assistance. And I imagine this requires completely restructuring how you think about workflows. Instead of designing processes for human handoffs between applications, you're designing them for AI orchestration across your entire digital environment. That's a massive mental shift for most business users.
Exactly, and this connects to another major trend we're seeing, spec-driven development. Microsoft just introduced GitHub Spec Kit specifically to address this challenge. The insight is that AI can move incredibly fast, but speed without clarity creates technical debt and misaligned implementations. So they're enforcing a spec-first workflow where you write detailed specifications before any code generation begins.
That makes perfect sense when you think about it. If you're handing entire workflows to AI agents, you need to be extremely precise about what success looks like up front. It's like that old programming saying garbage in, garbage out, but at workflow scale instead of just individual functions. How does this spec-driven approach actually work in practice?
GitHub Spec Kit provides templates, validation, and version control for specifications before they get handed to AI coding assistants. Instead of this generate and fix cycle, where you iterate through multiple rounds of AI output, you front-load all the clarity. The AI generates more accurate code because it has precise, unambiguous specifications to work from. It reduces the thrash significantly.
This is particularly important for solo builders and small teams where all the context often lives in one person's head. Formalizing specs creates reusable artifacts and reduces cognitive load when you're managing multiple projects simultaneously. But I'm also seeing this broader trend toward tech stack consolidation. How does that fit with this agent-first computing model?
Great connection. Organizations are actually reversing years of tech stack expansion, consolidating fragmented tools into what they're calling systems of context. Instead of navigating 100+ applications, they're using AI to synthesize scattered data into single sources of truth. The focus shifts from feature breadth to contextual integration, especially for revenue-producing functions like CRM and customer interaction tools.
So rather than adding more tools to solve problems, they're reducing complexity while maintaining capability through AI orchestration. That's a complete inversion of how most businesses have been thinking about productivity software. But what does this mean for the humans in these workflows? Are we looking at job displacement or role evolution?
It's definitely role evolution, particularly in software development. Developers are shifting from code writers to code orchestrators, directing AI tools, validating outputs, ensuring enterprise quality standards. The human value becomes architectural decision-making, system-level thinking, and quality assurance rather than line-by-line coding. But this requires mastering prompt engineering and understanding AI limitations.
That orchestration role seems much more strategic and higher leverage than traditional coding. But it also means developers need to evolve their skill sets pretty rapidly. Understanding how to structure workflows for AI delegation, knowing when to trust AI output versus when to maintain human oversight, these are fundamentally different competencies than what most developers learned in school.
Absolutely. And the timing is critical. We're seeing early adopters pull ahead rapidly because agent-first workflows create compounding advantages. If your competitor is still using AI to assist human processes, while you're using AI to replace entire workflow segments, you're operating at fundamentally different cost structures and iteration speeds. The capability gap grows quickly.
Which brings us back to that Codex adoption statistic. The 1,598 out of 1,600 people who aren't using these agentic workflows aren't just missing productivity improvements. They're potentially missing a fundamental shift in how competitive advantage gets built and maintained. But for those ready to make the transition, what's the practical first step? How do you move from application first to agent first thinking?
Start with one complete workflow rather than trying to transform everything at once. Pick something with clear inputs, defined outputs, and multiple manual steps you're currently doing across different applications. Design the agent workflow from the ground up. Don't just try to automate your existing human process. And critically, establish clear boundaries and verification checkpoints. The goal is delegation with accountability, not blind automation.
That incremental approach makes sense, especially since this requires learning new patterns of human-AI collaboration. And as these tools become more capable and accessible, I suspect we'll see this transition accelerate dramatically. The question isn't whether agent-first computing becomes mainstream, but how quickly organizations can adapt their processes and people to take advantage of it.
Jane, as we wrap up today's episode, I'm struck by how all these stories point to the same fundamental shift. Whether it's Gamma hitting $2.10 billion with 50 employees, or those Codex users burning through 500 million tokens daily, or GitHub restructuring their entire platform around AI agents, we're witnessing the transition from AI as productivity tool to AI as autonomous workforce, and it's happening faster than most organizations are prepared for.
Absolutely, Oliver. And what's particularly striking is the scale advantages this creates. Companies that successfully make this transition aren't just incrementally more efficient, they're operating at fundamentally different cost structures and speeds. The competitive gaps aren't linear, they're exponential. When one company needs 500 employees to do what another does with 50, that's not just a productivity difference, that's a structural advantage that compounds over time.
That's exactly right. And I think the most significant trend we're seeing is this shift from application first to agent first computing. Most people are still thinking about AI as better ChatGPT, but the real transformation is happening with users who've redesigned their entire workflows around delegation rather than augmentation. The capability ladder concept helps explain why this transition feels so sudden. We've crossed multiple rungs simultaneously.
Which brings us to what to watch for in the coming months. I think the key indicators will be adoption rates for agentic workflows, the quality gap between AI marketing promises and real-world reliability, and how quickly organizations can retrain their people for orchestration roles rather than execution roles. The technical capabilities are clearly advancing rapidly, but the bottleneck is becoming organizational adaptation and change management.
And keep an eye on platform consolidation. GitHub's aggressive moves toward becoming the AI development platform, the trend toward unified agent builders like Hermes, the push for spec-driven development, these all suggest we're moving toward more integrated, less fragmented AI tooling ecosystems. The companies that build the best orchestration platforms for this agent-first world are going to capture enormous value.
That's our show for June 12, 2026. The message is clear. AI isn't just getting better at existing tasks, it's fundamentally changing how work gets organized and executed. Whether you're building the next Gamma or just trying to stay competitive in your industry, understanding this shift from tools to autonomous workforce is going to determine who thrives in the next phase of business evolution. Thanks for joining us on Tech Daily. We'll be back tomorrow with more insights from the rapidly evolving AI landscape.